Hello, everybody. So let me get started here to show you how to run the regression analysis. It's your last assignment. 4 requires you to produce this regression analysis results. Here's your output. So you're going to have 2 tables. One is a descriptive statistics table. For this one, you'll run just a you'll run the frequency command, proc_freq. And then for weight, you run the proc univariate to get the mean, or you can just, whatever way you can just get a mean and a standard deviation. That's all we need here for that one. And then you can complete this table. You're going to complete it once without video games, and then once with video games. So basically, you're going to run this model twice. Then you're going to answer these questions here. Now, notice that this highlighted area in yellow, right? This is just an example. So I don't want to see this in your result. Okay, so one of the things you're going to do is you're going to upload this document. You're going to upload this document to the Kendall Hunt site. Okay, so you're going to upload it there, but then you're also going to answer questions. So where it asks you to upload, well, I'll show you that in a second, but let's go ahead and get the work done. So I'm going to use a different, I'm going to provide you this code, and I'm going to use a different way of a different way for analyzing for conducting this that adds everything that we need in there. So proc_reg is the process that we use to run a regression analysis model, right? But we're going to add things here. I'm going to add graphics so that it can produce some really nice graphics for you. We're going to add a print statement. 'Cause one thing we need to do is look at this. These are called studentized residuals rather than standardized residuals. We want to look at those. They're actually more accurate when it comes to looking for outliers, and that's what I'm interested in here. We're going to look for outliers. And but we're going to run the proc_reg first, and we're also going to ask for the stuff that we need to conduct our diagnosis of multicollinearity, which is tolerance and the variance inflation factor. Also, we're asking for the studentized residuals. We're going to create an output data set that includes the studentized residuals, and then also we're going to get a value that gives us basically how many standard deviations are any value is away from the mean, because that's what we're looking for, residual values that are over, say, 3 standard deviations from the mean. So we're going to get that result. We're going to print them. So you're going to have a new output file, just like the original file, but including these studentized residuals. And then also we'll print anyone that's greater than or equal to 3, right? So that's what we want to see, because the ones that are considered greater than or equal to 3, those are what we're going to be worried about. Those, again, you don't have to necessarily do anything about them, but they're just interesting to look at. They may be problems, they may not. And just to do this, I'm using the my first data set instead of the data set you're using. So I'm going to provide these data for you as well. I mean, these code for you as well. But let's run it and take a look at this. So in this model, I'm looking at whether or not perceived physical appearance will have an effect on depression. I'm going to control for sex, body mass index, and self-esteem. So first thing I'm going to do is run the model without physical appearance in it, right? So in this case, I just want to get the R square. And I just want to get the values here, right? I just want to get the values so that we complete the table. So I'll just highlight everything that I want to run. Again, I have to turn the graphics on and then turn them off when I'm done. So right here, and then we do all these other. So there's 3 separate three separate processes being run over here. And then here's my output. So what are we going to look at? We're going to look at variance inflation factors and tolerance to look for multicollinearity. Tolerance is the proportion of the variance that in each variable that's not accounted for by the other predictor variables. We're not including depression. Depressions are outcome variable here, right? So we want these to be around 1, because 1 means that the entirety of the variance we see in our dependent variable is not accounted for by the others. Variance inflation factor is 1 divided by the tolerance. Again, it's redundant. Here's your R square, 0.5155, adjusted R square. And again, this is shows model complexity, takes that into account. It's not really bad here at all. Here's your F table. Every analysis and regression analysis provides an F table. Here's your plots that you want to look at. So here I was just showing one of your fellow students, Alyssa Kelly, how to run this, but you can use either what I showed her or this. This is actually provides additional information to answer one of the questions. But if we were looking at the predicted value and the residual, we're going to look at the studentized residual and the predicted value. So really it's this one right here in the middle. So we'd like everything to stay within this region here. There's some values that are outside here, but I don't see this as a problem because the vast majority of values are within this clustering right here, right? Within 2 standard deviations. Now, there are some that are out there, so that something you might want to investigate, but I don't see any major violation of what we call homoscedasticity of variance. We want the variance to be constant across different levels of the predictor. Doesn't seem to be anything, but again, this is a little interesting. That's all I could say. It's interesting. This shows our residuals are normally distributed. We want them to be normally distributed. They're mostly to a large extent, they look normal. So that's the normal curve right there. What I'm interested in is, so we can say there's no multicollinearity here. Are there any outliers? I'm going to look at my standardized residuals. This is the residual. That's just the difference between the predicted value and the actual value of depression, like 24 minus 17.0, whatever, 945. And this is the difference. And then here's the studentized value. So we want these to be within 3. So this doesn't look like there's too many that are outside of 3. I haven't seen any yet. Maybe there'll be some. But I did ask for this to be printed out as a result, and I do get that at the bottom here, right? Tells me that observation 25, 215, 231, 327, and 364 are greater than 3 standard deviations from the mean in terms of residuals, or the residuals are, right? So gives you the scores here. So you could actually go and investigate. That's not that many. We have 393 cases, and there's only 1, 2, 3, 4, 5 that have that value. I wouldn't be so worried. I mean, again, I would investigate them just to make sure there were no data entry errors. Data entry error could cause that problem, okay? So, like, let's say if I were writing a report, I would probably want to write about, oh, this is without perceived physical appearance. So let's just keep in mind that our R square is 0.5155. And let's go back here and add physical appearance. I think I can just hit Control Z. There it is. And I'll run it again with physical appearance, and this will give me the difference in the R square, right? Nothing's really changed here. Although this you'll notice that self-esteem, the tolerance has gone down to 0.6, and then so has physical appearance. So there's some correlation here probably between self-esteem and physical appearance. However, I'm not so worried about this. I'd be worried if my tolerance was around 0.1 and if this VIF was around 10. So I'm not concerned about that. I still say I don't have any multicollinearity. So you see my R squared didn't change that much. So this is telling me that, this physical appearance didn't really add anything to the model. Indeed, if I look at the p-value, it's not significant. Then you can again investigate these. This looks actually a little better now that we included physical appearance in there. Let's see. This shows you the impact of each of these variables alone on on depression. So it seems like, if anything, body mass index could be something that would be concerning in this case. Because see how it's wider here and then narrower here. So that could mean that it does a better job predicting, body mass index does a better job predicting depression at higher levels than at lower levels. But most people are clustered around here. So I don't see a huge issue here, but something that I would be a little bit wary of, but maybe not necessarily completely wary. Because I mean, I look at my total results and it looks like it's okay with, this includes all all the variables in the model. And then again here, let's investigate the residuals, and still 5 of them. So this is the model, the second model, right? So when I fill in that table, what I'm going to put in that table that I showed you, you're going to put in the parameter estimate, that's your B value, the standard error, and your P values. Those are the things that you're going to put in. So let's go back here, right? B values, standard error, and P values. And notice this one does not include video games. This one would include video games. And then to write up my results, I would use the B values and the P values, right? And I'd go ahead and read this something like here, like in this model, I see that, well, first of all, we know perceived physical appearance does not have a significant effect on depression. And then I put P is equal to 0.3984, because we know that P value is way above 0.05, 0.10, 0.01, whatever you chose. But like if I was looking at something that is significant, I'd see self-esteem, though, had an effect, a significant effect on depression. Indeed, each unit increase in self-esteem resulted in a 7.33 point decrease in depression, holding all other variables constant, right? If I were to look at the standardized estimates, these ones here you can actually directly compare. I see that self-esteem has a standardized estimate. So this is not the residual. This is just the standardization of this parameter estimate. It's like 0.65. I'm ignoring the sign for a second. It's 0.65, right? It's way larger than any of these other values. So this tells you that this is the most important predictor variable here. Okay. All right. Any questions, let me know. So thank you, guys.